Hello everyone, welcome back to our Python programming series. Today we are diving into a fun and educational Python script that demonstrates key object-oriented programming concepts like abstraction, encapsulation, inheritance, and polymorphism. This code creates a turn-based duel game between heroes like FireMage and IceSorcerers. I will walk you through every line of the code, explain what it does and why it matters. By the end, we will reinforce what we have learned so far. Now let's get started by importing required libraries. So first we will import ABC and abstract methods. We will import them in order to use abstract base classes and abstract methods. So it's done. Now I will import random, because this built-in library provides random numbers for things like spell damage and deciding who goes first in a duel. Now let's move to the hero class. First, we should define a hero class which inherits from ABC, making it an abstract base class. So class hero ABC, and under that abstract method define cast spell self opponent. And if you remember, we can use pass here in order to return nothing and define another abstract method define status self and pass again. We define the hero class which inherits from ABC. Then, using abstract method decorator, we mark cast spell as a method that any subclass must implement. It takes an opponent parameter, suggesting it will be used to attack another hero. Similarly, status is another abstract method that subclasses must implement to show the hero's current state. The pass statements are placeholders since this is an abstract class. So this ensures any hero we create, like a FireMage or IceSorcerer, must have these two methods, enforcing a consistent interface. Next, we can have a base hero class. So let's type abstract class, then base hero class. There are more professional ways for writing comments, but I'm just taking notes so you can follow. Now class base hero, let's call it base hero, inherits from hero, so it will include some generalized features, and define its constructor self name and mana self dot name equals name self dot mana equals mana self dot points equals 0. So all of these are private. This class will serve as a concrete base for specific hero types and initializes 3 private attributes. The double underscores before name, mana, and points make them private, so they can't be accessed directly outside the class, hiding the internal state. Now let's define getName, def getName, self, return self.name. These are getters, and def get mana self, return self.mana, and def get points self, return self.points. So these are our getters and initializing, and they can access the private attributes. So it's a controlled access and another part of encapsulation. Now also define our take damage function. They takes damage by specified def take damage self damage self dot mana, so it will drain mana if we take damage. Can also name it as health, but since we are dealing with mages, I thought it would be more appropriate. Max 0, so minimum value will be 0, it won't go below 0. Self dot mana minus damage. Write a function to add points. Def add points self dot points plus equals 1, and this method increments the hero's points by 1 when they win a duel. It's simple but important for tracking victories. After that, a random damage generator, so cast spell function, and say random damage between say 1 and 5 using random dot rand integer function. Define cast spell self opponent damage equals random dot rand int 1 5. This will generate a random integer between 1 and 5, and opponent dot take damage with by an amount of damage. So it calls the opponent's take damage method to apply the damage. Let's also return a string of self dot name casts spell for damage. So if we take a look, our cast spell function is complete. Now we should define status function for printing. Define status self return f self dot name mana equals self dot mana points. I will break a line here, equals self dot points. This method, also required by hero, returns a string showing the hero's name, current mana, and points. So this BaseHero class gives us a generic hero with basic functionality, encapsulating data and providing a foundation for more specialized heroes. Now let's move to FireMage class, which shows inheritance and polymorphism. So let's define class FireMage, say BaseHero. Define init self name mana, and in addition to that, as a special attribute, blaze. And super, if you remember this call, it will call the base class init. So we call base class constructor name mana and set special attribute in this function only. So blaze equals blaze. FireMage inherits from BaseHero, so it gets all its methods and attributes, and blaze represents extra fire damage. Okay. Initializing with blaze, and let's define cast spell with blaze. So define cast spell self opponent damage equals random dot rand integer 1 5 self dot blaze opponent dot take damage and return f self dot get name unleashes fireball for damage. So it overrides the cast spell method, which is polymorphism, same method name, different behavior. Here damage is calculated as a random number again, plus the blaze value, making FireMage's hit harder. And also, special status function for FireMage, define status self. Since base class defines a function for status, we will use it, and it returns a string, so we can type base stat equals super dot status and return f base stat. Besides that, blaze self dot blaze. So it uses base class status function for printing basic status, and it also adds self.place. Now let's define a class for IceSorcerer. Class IceSorcerer BaseHero. So it will initialize with freeze, opposite of blaze. It's a special skill for IceSorcerer, so define init. It will look like self, name, mana, and freeze. So super dot init name mana self dot freeze equals freeze. Now let's define cast spell with freeze. Define cast spell self opponent damage equals random dot rand int 1 to 5. So let's something different for freeze. Let's type something like this. If random dot random, using random again, do not confuse with this rand int, it's different, it's damage. But now let's add some probabilistic feature. So if random dot random less than self dot freeze divided by 10, damage is multiplied by 2 and opponent takes damage by this amount. Damage. Random.random generates a number between 0 and 1 and we compare it to self.freeze divided by 10. For example, if freeze is 3, there is a 30% chance 0.3 that the condition is true. So if the freeze triggers, damage is doubled. If self.freeze equals 5, then 50% chance, and if self.freeze equals 10, it's 100% chance. Return self.getName freezes opponent.getName, and I will break a line here. So let's do this for damage. And let's remove this. And after that, type opponent dot take damage, and return. If it can't trigger freeze, so we will type self dot get name casts ice bolt for damage. So we are done in this function. So this function is special for IceSorcerer and works in a probabilistic way. And as the final one, status function for IceSorcerer. Define status. Base stat equals super dot status return f base stat with freeze self dot freeze. And let's define MysticDuel class. It will help us to start battles between heroes, so let's define it. Class MysticDuel define init self.heroes equals an empty list. Initialize MysticDuel and heroes are not added yet to our list. Now define a function name add hero. So add a hero to the object list. Define add hero self hero self dot heroes dot append hero. So it will just add hero to the list. Simple but essential for tracking players. Now let's define duel function. It will take two hero names as input and manage the duel. Define duel self hero 1 name hero 2 name first hero. Let's define a loop for hero. Let's use for loop for hero in self.heroes. If hero.get name equals hero 1 name, we should first define an object assigned to none before entering the loop. So let's define, so it's hero 1 equals none. Then if we find it, we can assign it. So hash1 equals hero. And here we should break because we will define another loop. So break. We will do the same for hero 2. So hero 2 equals none. So we will say second hero and find and assign first hero and find and assign second hero for hero in self.heroes. If hero.get name hero 2 underscore name equals hero break. If not h1 or not h2, so we check if either hero is missing not h1 or not h2, and also check if either has 0 or less mana. So type or h1 dot get mana less than or equal to 0 or h2 dot get mana. So if we want to break a line, can use parentheses or backslash. I will use parentheses. Less than or equal to 0. We will return duel failed. So if no match is found, none is returned for heroes, and we check mana and we check for missing heroes. If so, the duel can't happen and we return duel failed. If not, we can first announce the duel. Let's print F, new line, and hero 1 name, hero 2 name, turn equals random.choice h1 h2. Random.choice randomly picks which hero goes first, and other equals h2 if turn equals h1, else h1. This is a shorthand for if turn equals h1, other equals h2, else other equals h1. After that, print turn dot cast spell on other. If other dot get mana less than or equal to 0, turn will win points, so we call at points function. And we return f turn dot get name wins and earns a point. We have made a random choice. After that, we set other to the opponent based on who goes first. The first hero casts their spell and we print the result. If the opponent's mana drops to 0 or below, the attacker wins. The winner gets a point via add points. Else, what happens? If the duel isn't over, the other hero should cast their spell. Print other dot cast spell on turn. If turn dot get mana less than or equal to 0, other dot add points. Return f other dot get name wins and earns a point. So if duel isn't over, the other hero casts their spell. If the first hero's mana drops to 0, the second hero wins and gets a point. If neither hero's mana hits 0, the duel continues and we return that message. So we will return duel continues. Finally, let's look at the example usage in the main block. So let's define main if name equals main, game equals MysticDuel, so it's our manager, and fire equals FireMage, say blaze with 20 mana and 3 blaze. Ice equals IceSorcerer named Frost with 20 mana and 5 breeze. Now we will add these heroes to game. Add hero fire game.add hero ice. Print game.duel since it returns strings according to situation. Blaze versus Frost. And print fire.status. After that, print ice.status. This ensures the code only runs if the script is executed directly, not if it's imported as a model. And we create a MysticDuel game instance, then we create our heroes, add them both, start a duel between Blaze and Frost, printing the result, and print the status of both heroes after the duel. Now let's run it and see the results. If you remember, we defined them with 20 mana points. Now it says Blaze versus Frost. Blaze unleashes Fireball for 5 damage. Frost freezes. Blaze can fix the string and leave a space. Then run it again. Okay, So, as you can see, it's probabilistic. Blaze unleashes Fireball for 7 damage, Frost casts Ice Bolt for 3 damage, Duel continues, and mana points are dropping. Now let's run it again. It casts Ice Bolt, run it again, and it says Frost freezes Blaze for 8 damage, Blaze unleashes Fireball for 6 damage, Duel continues. So let's duel a few times more and print the results. As you can see, Blaze wins and earns a point, so the game continues until one of the heroes is defeated. Say Blaze goes first here, and again and again, and as you can see, Frost attacks are probabilistic. Sometimes it attacks with regular Ice Bolt, sometimes with Freeze attack. In the end, Blaze wins and earns a point. So, a fantastic example of OP in Python. The hero class defines a blueprint. Private attributes and getters protect data. FireMage and IceSorcerer built on BaseHero, and each hero type implements cast spell and status differently. It's a simple but powerful game that you can expand by adding more hero types for complex rules. Try running this code yourself, tweak the damage range, or add new heroes. If you found this helpful, like and subscribe for more Python tutorials, and let me know in the comments what you would like to see next. See you in the next video.